The seventh chapter in Kuhn's The Structure of Scientific Revolutions is titled Crisis and the Emergence of Scientific Theories, in which Kuhn elaborates on the conditions which he suggests lead to scientific revolutions. He identifies several historically important scientific theories and examines the circumstances surrounding their acceptance in detail. Kuhn poses the question of how new theories are accepted in the place of older, more well-established theories. He gives the example of Newtonian mechanics and the occurrence of early advocates against an absolute model of space in favour of a relativistic model. However, what is interesting is that these criticisms were apparent only for a short while before disappearing from the scientific debate. Kuhn argues that this occurred because there was no crisis in science. In other words, the normal science which he discussed previously was not producing consistent anomalies, which would cause the scientists to question the validity of the underlying theory. As a result, there was no impetus to take this debate further until the late 19th century, when this became relevant to the contemporary debate in physics. Kuhn uses physics to generalize to science, whilst making no mention in this chapter of those branches directly relevant to the neurosciences. Nevertheless, it's interesting to note that in the neurosciences, several theories do coexist, which are currently relevant and which offer different perspectives on the same set of phenomenon. Kuhn's arguments hold relevance to a winner-takes-all approach to theory building, or else the neurosciences have been in a persistent state of crisis according to his arguments. This, though, doesn't seem consistent with the many practical benefits that these different theories have produced, and so maybe the neurosciences represent a branch of science which merit their own philosophy of science.